Imagine a football player running down the field and a football flying through the air. Which one is harder to stop? Your first instinct may be to say the football is moving faster, so maybe it has more motion. But the player has much more mass. Momentum is the quantity that helps us combine both ideas: how much mass something has and how fast it is moving. In this video, we will define momentum, identify its units, explain why momentum is a vector, and then compare the momentum of a football player with the momentum of a football. Linear momentum is the product of an object's mass and its velocity. The symbol for momentum is usually written as a lowercase p. In words, momentum equals mass multiplied by velocity. Mass tells us how much matter the object has, and velocity tells us how fast it is moving and in what direction. So, if an object has a large mass, a large velocity, or both, it can have a large momentum. This is why slow moving truck can still be very hard to stop. Its speed may not be extremely high, but its mass is very large. Momentum is a vector quantity. That means it has both magnitude and direction. Since mass is a scalar and does not have a direction, the direction of momentum comes from the direction of velocity. If the object moves to the right, its momentum points to the right. If it moves to the left, its momentum points to the left. The unit of momentum comes from multiplying the unit of mass by the unit of velocity. Mass is measured in kilograms and velocity is measured in meters per second. Therefore, momentum is measured in kilograms meters per second. A common mistake is to treat momentum as just another word for speed. But two objects can have the same speed and very different momentum if their masses are different. Similarly, a lighter object can compete with a heavier object only if it is moving much faster. Momentum always combines mass and velocity together. Now let us use this definition to compare a football player with a football. In this example, we compare the momentum of two very different objects, a football player and a football. Part A asks us to calculate the momentum of a 110 kilogram football player running at 8 meters per second. Part B asks us to compare that with a hard thrown football with a mass of 0.41 kilograms and a speed of 25 meters per second. Before calculating, let us make a prediction. The football is moving faster, but the player has a much larger mass. The player's mass is more than 250 times larger than the mass of the ball. So even though the ball is moving faster, we should expect the player to have much greater momentum. This is the point of the example. Momentum is not decided by speed alone. We must multiply mass and velocity. For both objects, we will use the same relationship. Momentum equals mass times velocity. We will calculate the player's momentum first, then the football's momentum, and finally compare them using a ratio. Let's calculate the momentum of the football player. The mass of the football player, m sub b, is 110 kilograms, and the speed of the football player, v sub p, is 8 meters per second. If we use the equation, the momentum is equals mass times velocity, we get the magnitude of the momentum of the player, mass of the player times the speed of the player, which is 110 kilograms multiplied with the speed 8 meters per second, and we get 880 kilograms meters per second. So the football player's momentum is 880 kilograms meters per second in the direction he is running. Now calculate the football's momentum. The mass of the football is 0.41 kilograms. The speed of the football is 25 meters per second. Now, the magnitude of the momentum of the ball is 0.41 kilograms multiplied with 25 meters per second, and we get 10.3 kilograms meters per second. So even though the football is moving faster, its momentum is much smaller because its mass is so small compared with the player's mass. To compare them, divide the player's momentum by the ball's momentum. P player divided by P ball, and we get 880 kilograms meters per second divided by 10.3 kilograms meters per second, and we get 85.9. This means the football player has about 86 times more momentum than the football. These results match our prediction. The ball has the greater speed, but the player's much larger mass dominates the comparison. The important takeaway is that momentum combines mass and velocity. When you think about how difficult it is to stop a moving object, do not look only at speed. You must also consider mass, and you must remember that momentum has direction.